Okay, here we are calculating some factorials. So remember, 7 factorial just means 7 times 6 times 5 times 4 times 3 times 2 times 1. So if I wanted to calculate all of that, I could use my calculator, and I could do 7. Let's actually put these in parentheses. 7, and then I go math over to probability, and then 4 is the factorial button. If you have the blue calculators, from the top left, you go down 1 and right 1, and there's the PRB button, the probability button. If you push that, you'll find factorial inside there. So 7 factorial times 2 factorial divided by 8 factorial times 4 factorial. And it's going to spit out that number. Now, there is another way to do it. We could just write it all out. So 2 times 1, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and 4 times 3 times 2 times 1. And I lined these up specifically so that I could cancel things. And everything on top is gone. And on bottom, I have 1 over 8 times 4 times 3. So 1 over 96. Okay. And if you think about it enough, you really don't need to do all that work. Maybe. Uh-oh. Wreck-It Ralph broke the internet. Okay, we're back up and running. So if you look at this 6 is going to cancel everything in the 7 except the 7, right? And this 4 is going to cancel everything in the 3, but there will be a 4 left over. So it's just 1 over 28. So a lot of times you can just look at it and then figure out which numbers did not get canceled. Okay? Or you can write it out, or you can use the factorial buttons. Okay, now on to combinations and permutations. So remind me, if AB is equal to BA, what do we call that? If order doesn't matter, and what sort of situation is that? Combination. Good. So this is a combination. How do we calculate combinations? We use the NCR button. So if I was saying we have a class of 20 kids, 5 of you get A's, is AB the same as BA? Yeah. If 5 of you are going to get an A, it doesn't matter who I say first. So that would be 20 choose 5, or a lot of times we write it this way. 20 choose 5. Okay. What if I had a bag of 20 letters and I was making a 5-letter word by pulling a letter out, setting it down, pulling a letter out, setting it down, pulling another letter out, setting it down? In that case, is the word AB equal to the word BA? No, those are two different words, right? And this is called a permutation. And I can figure that out by doing 20p5, but I never actually use that. What's the other way to calculate this? I just line out 5 letters. How many options are there for letter number 1? 20. Okay. And then what about letter number 2? Well, did I put the letter back in? No. So this is going to be 19, which means that AA is not a possibility. And what do we call it when AA is not a possibility? A permutation without replacement. So if you don't stick it back in, it's without replacement. And then the third letter has 18 choices, and the fourth 17, and then 16. Okay? But what if I do put the letter back in? So this is a permutation without replacement. If I do put it back in, then it's a permutation with replacement. And how is that calculation different? My first option has 20, just like before. What about option number 2? 20 times 20 times 20 times 20, which means that AA does exist. And there's no fancy button on the calculator. You would just do 20 to the 5th. Okay? So here, it just wants you to plug those into your calculator using the probability buttons. So, to do that, I push 10, math, then I go over to probability, and NPR 5, and I get 30,240. If I wanted to write it out, I have 5 options, and there are 10, then 9, then 8, then 7, then 6 choices. You multiply all that together, and you get 30,240. Okay. All right. So we want to choose 3 letters without replacement from the letters A, B, C, D. How many ways can this be done if the order is relevant? So that means 12, well, let's say AB is not equal to BA. So if order matters, then we write the not equal to, which is a permutation. And the next one says order is not relevant, so AB is equal to BA. And this is basically the difference between lining up for lunch and choosing a group of people for lunch. Do we still do that in elementary schools, line up for lunch? Oh, yeah, that's how we get kids into the military. If you're a good marcher, then we'll recruit you. So if I said 5 of you get to go to lunch today, then that's just a group. That would be a combination. Order is not important. But if I said Carly gets to eat first, and when she's done, then Addie gets to eat, and when she's done, then the other Addie gets to eat, and then Logan gets to eat, right? That order matters. You're eating at a different time. So for a permutation, I could do 4P3, or the way I would do it is we have 4 options, and then 3 options, and then 2 options because this says without replacement. And then for letter B, it would just be 4 choose 3, or 4C3. That's how we calculate those. Suppose we want to choose 6 objects without replacement from 9 distinct objects. And if order is not taken into consideration, that means AB is equal to BA, then we would just do 9 choose 6. So I come down here, 9 math C6. So there are 84 ways to do that in a combination. If order is taken into consideration, that means AB is not equal to BA. And we have 6 spaces. 9 times 8 times 7 times 6 times 5 times 4. Or I could do 9P6. All right. Okay. So, this one's going to be kind of tough. There are 6 people taking part in a raffle. Hans, Jim, Lena, Omar, Ravi, and Sue. Suppose the prize winners are randomly selected from 6 people. Compute the probability of each of the following events. So event A says Jim is the first place winner, Ravi is the second, Hans is the third, and Sue is the fourth. Okay. So is there an order in event A? Yes, there's definitely an order. Okay. So how many ways are there to pick Jim as the first place winner? Well, we have 6 people. So if Jim is going to win, there is a 1 in 6 chance that Jim is the first person. Okay, does everybody get that? Now we move on to person number 2. What is the chance that Ravi is the second person chosen? That's a little bit harder, right? So we already picked Jim. Are we going to put him back in the raffle? How do we know? Doesn't really say, right? But we're assuming if you win, you don't get put back in. Okay? So what is the probability that Ravi is the second person chosen? Well, how many names are still in the raffle? 5. So Ravi has a 1 in 5 chance of being chosen. Okay? Hans, being the third, has a 1 in 4, and Sue has a 1 in 3. So that would be 1 over 30 times 12 is 360. Okay? Okay, does everybody understand that? So I am not calculating how many ways it can happen. I am calculating the probability that it will happen. So instead of saying there are 6 options for person 1, I say Jim has a 1 in 6 chance of being the first person. Okay. Now, how is this different? The first 4 prize winners are Hans, Omar, Jim, and Sue. How is that different from A? So over here, the winners are Jim, Ravi, Hans, and Sue. Okay, so we know that those 4 people win in that order. And event B says, what are the chances that these 4 people win? Order doesn't matter. So over here, if I draw Ravi for the first place, then I'm out. I lost, right? So this HO is exactly the same thing as OH. So this is a combination. And there are 6 people, and we're choosing 4 of them, right? So 6 choose 4. Let's pull this up. So 6 choose 4 is 15. So there are 15 ways to do this. So what's the probability? No. There are 15 ways to pick those 4 people. But how many total options are there? Well, oh, not that one. How many ways are there to pick person number 1? 6. And person number 2? Not 6. 5, 4, and 3. So that is 360. So there are 360 total ways to draw out 4 names, and 15 of them include those 4. So it would be 15 out of 360, and then you just simplify it. Okay. What's that? Oh, 1 over 24. Thanks. Okay. Could we have done that here? We could have. We could have said 6 times 5 times 4 times 3 is 360. Okay. Now watch this, because this is a little bit strange. So there are 360 total possibilities. How many ways are there to put Jim in the first spot? 1. You put Jim in the first spot, right? How many ways are there to put Ravi in the second spot? 1. And Hans in the third spot? 1. And Sue in the fourth? 1. So we would do 1 out of 360. So there are actually 2 different ways to do A. Okay, let's do another one. All right. We have 7 streets to be named after 7 tree types. Okay. So how many ways are there to name these streets? Well, the first street has 7 options, and then 6, 5, 4, 3, 2, and 1. To calculate that, all I need to do is 7 factorial, and I get 5,040. So there are 5,040 ways to name these 7 streets. Okay? How many ways are there to call the first street Spruce, the second street Ash, and the third street Fir? Well, how many ways are there to put a spruce here? 1. We call it Spruce. Call this one Ash? 1. Call this one Fir? 1. So 1 times 1 times 1 is 1 over 5,040. Okay. All right. What if I wanted to know that the first 3 streets are Willow, Pine, and Spruce, but the order doesn't matter? Well, how many ways can you rearrange Willow, Pine, and Spruce? That would be 7C3. So 7C3, 35. So this is 35. We divide that by 50/40. And that is this one. Okay. Got it? All right. Get to work.